eDNA is short for environmental DNA and is just the stuff that all organisms put out into the environment as a matter of being alive. They shed cells into the water, the air, or the soil. We pick it up, sequence it, and we can tell you what lives nearby. And DNA gives you this incredible high definition, high resolution view of life on the planet. And it felt like that was the perfect thing to be able to use to look at things in the ocean. Actually, we started at the Monterey Bay Aquarium because they gave us access to their big tanks. And we took, 1 liter samples out of 4 million liters. And so we sequenced the DNA out of that tank and we saw, the tuna and the fish and the other things that you could see with your eyeballs, and we knew were in the tank. Then we also saw a bunch of other species that we knew were not in the tank. And we thought, well, that's got to be a mistake. And it became clear that the DNA techniques were so sensitive that we were seeing not just the fish in the aquarium, but the fish that were in the food that they were feeding the fish in the aquarium. Since then, it's really exploded in lots of different ways. We still take bottles of water. What's changed is all the things we can do with the information we're getting out.
The eDNA Collaborative is a center based at the University of Washington. We are a hub of information and resources. We have a big emphasis on building networks, but really what we're trying to do is put people together, put ideas together, be a friendly, familiar place for people to come who have questions about eDNA or want to be connected to the community. For eDNA, success would be that it becomes a commonplace tool. The tool in the toolbox of researchers, of government agencies who are doing any sort of monitoring.
One of the real impacts we've seen is now NOAA is looking to do stock assessments for commercial fisheries and fold eDNA into their stock assessments. So to be able to go from this sort of experimental technique in the Monterey Bay Aquarium and see that get traction on Capitol Hill and get traction in federal agencies, that's remarkable.
I think not every scientist thinks about impact. We think about impact every day, and what's been really a huge opportunity is having the time and space to make those connections and think about how, very intentionally, how we are going to use the science to make it accessible.